Hey, what's up? Welcome to this practical React security course in which we're going to talk about dependency vulnerabilities and how we can prevent adding malicious code to a code base by using tools like SNCC, session management with regard to authentication and authorization, sensitive data in React apps, how to protect our React source code from being re-engineered by malicious users, HTTPS, and learn how to use static application security and code quality tools like SNCC, HCL, AppScan Code Sweep, and DeepScan. So first of all, I'd like to briefly go over why security is important. And of course, this is not an exhaustive list, but these are definitely some important points. So you want to arm your application against cyber attacks, right? So you want to prevent sensitive data from being stolen, and identity theft can simply be, a hacker acting on behalf of, some of your real users. Also, the cleanup of a security breach can be much more expensive compared to, having secured your application in the first place, right? You can get fines, you might get yourself in trouble where you need to hire experts to, solve all this stuff and to report all things that went wrong. For example, if you have sensitive data from like your users that has leaked, then you have to report all these things. Altogether that can become quite expensive compared to just having spent maybe a couple of hours taking a close look at your security. But also the potential success of both the app and the company can be called into question, because imagine some sensitive data of your users leaking to the outside world. That can definitely harm your reputation as a tech company. So let's dive into the first topic: dependency vulnerabilities, right? Dependencies are simply packages that you use in your app, right? So for example, React in and of itself, you can consider that being a dependency, but also React has dependencies, right? So the problem is that a lot of times people, they download all sorts of dependencies and pretty much tools to make their development experience easier, but they forget that the moment you download someone else's code, it becomes your code. You have to take full responsibility over what you just downloaded. And a potential problem there is that you're downloading malicious code, right? If you download a library, for example, that could contain like thousands or even tens of thousands of lines of code. And I can imagine that you don't have the time to, read through that entire piece of code you just downloaded. But the problem there is that it could potentially contain malicious code. And people that create that malicious code, they often want to spread it as fast as possible. And libraries, which, some have even like millions of downloads every week, are a great way to do that. It can go viral in a matter of days. So let's take a look at a couple of examples of how people can do that. So, there's essentially two ways. You either create a new package or you add some code to an existing package. Let's take a look at the, creating a new package. So the first one is a Trojan horse. And I'm not sure if you heard about the Greek myth. It's a great story, actually. It's about, the Greeks and the Trojans that were in a war. And well, eventually the Greeks pretended that they were sailing away so that they were, kind of like leaving the war. And they left a big wooden horse as a sort of victory trophy. And then the Trojans, they brought in that wooden horse in the city of Troy to celebrate, their victory. What they didn't know that in that wooden horse was like a complete elite force of soldiers that then at night, they actually got out of the horse, and the idea is then that they destroyed the city of Troy. Now in software, we speak about a Trojan horse if you have malware, which is malicious software, which is being disguised as legit software essentially. So let's imagine someone creates a React library that aims to make it easier for developers to build React apps, and maybe it works, but in that code, and that's of course something you don't know, is some malicious code that can harm either you or your users. Another example is typo squatting, which essentially means that you are using typos that are being made by people. So a very popular package, for example, is Mongoose, which is used for Node.js apps if you're working with MongoDB. But imagine someone, instead of typing mongoose, they type mongoose, right? So, and if we go right here, this is the npm package, and you can see that it's a security holding package. So as you can see right here, it says to avoid malicious use, npm is hanging on to the package name, but if you really wanted, they can give it to you. And there have been cases where someone created a library with a typo, but it was very similar to a very popular package that contained malicious code. And you can see this package, even though it's not, it is essentially nothing, it still gets like 581 downloads every week. Now, we're not going to go over all the things right here, but to give you another example of, for example, trying to infect an existing package, you can inject some malicious code into the source code by simply committing as a maintainer. And a popular way to do it is so-called social engineering, right? So let's imagine I want to inject some malicious code, and I want to do that in a very popular package. So what I could do, maybe I can try to find out who the maintainers are, and maybe I find out that one of them is actually living pretty near. So I will then, for example, shoot him a message on Twitter, and I will say, you know what, like, I really appreciate your work. I'd like to do a podcast with you because you are inspiring so many people. So the guy thinks like, okay, well, cool, sure, let's do a podcast. And then, after the podcast, you maybe invite him for drinking a beer, and he kind of like becomes sort of friend, right? And the idea is that through social engineering, for example, when we're then in the pub drinking a beer, I can then tell him like, hey, like, I'd like to contribute to the project. Could you maybe make me a maintainer? I have some nice ideas to add that to the project. And he says, yeah, sure, I can give you the permission to make commits. And then, well, then I can add the malicious code. But of course, there are so many different, ways to go over this. But the thing is just that there are a lot of ways to add malicious code to open source libraries. But keeping that in mind, of course, you should understand that, security vulnerabilities are not always because of malicious code. Sometimes it's, can imagine that in about a week or like a month from now, we will find out about new vulnerabilities which currently no one is really aware of, right? So it doesn't always have to be someone adding a bad piece of code, but it can also be, some new security problems that come to light. The next thing I like to talk about is so-called the dependency hell. So if you do npm I install package, right, then most packages, on average, every package has 4 dependencies itself, right? So they have, well, let's say in this case, they have 3 dependencies. And in some of those packages also have dependencies. So you get like a whole tree of dependencies. So if you're installing React, for example, with Create React App, if you look in your package.json file, you see about, a dozen, or depending on what kind of version of Create React App, you might have like 20 dependencies, something like that. But you have to consider that, React, if you're using it with Create React App, you're actually pulling in almost 2,000 dependencies at the time of recording this video, right? In the past, this has been closer to 1,000. Now it's closer to 2,000. So it's, you got to imagine that you are importing like a crazy amount of dependencies. So now you might ask yourself, what are the solutions to prevent dependency vulnerabilities? And there's a couple of actions you can take. First of all, I would recommend to not install unnecessary libraries. I see a lot of, especially junior developers that are, new to React, and, they find out about npm and all the packages that are available. And, they think, well, that's very easy, like for very simple stuff. They start pulling in libraries, which, you should, of course, it's a trade-off, right? It's a trade-off between, creating your own custom solution or pulling in a library. And I can definitely tell you that for a lot of use cases, it just very, perfectly fine and common to pull in a dependency. But there's, for example, also packages, for example, like social, like the login with Facebook and Google and GitHub and stuff like that. There are libraries where you can like pull in those buttons. I personally would never do that. I would just create that button myself, add a little bit of styling. It doesn't take me a lot of time, and it just provides me from having to pull in another dependency. So be a bit critical about what you're actually pulling into your app, right? Ask yourself, is it really necessary, or can I simply, make this myself? Another good approach is to try to install well-maintained libraries. And I usually use two tools to analyze the libraries. So the first one is called OpenBase, which is kind of like a tool where you can search npm packages. You can also do that through like the official npm website, but I like OpenBase because it gives you a little bit more information. So let's imagine we want to download the library, for example, for like a slider carousel, right, in React, which would make perfectly sense to download the library for that, because if you have to do that, like create that like custom, that can be a pain in the ass. So I would do something like React carousel, right, something like that. And if you look right here, you will see it gives you some details. Some libraries there's actually people that can leave sort of like reviews about the package, and but you can also see like the amount of GitHub stars and weekly downloads, the last commits. Of course, they are no guarantee that it's a safe library, but generally speaking, like the bigger libraries that have like commits that are not like from years ago, and have quite a bit amount of like GitHub stars and have a good user rating most of the time, these are the packages you should prefer over, for example, a package that just has like 13 downloads a week. So right here you can, for example, well, let's take Swiper, which I've also used myself before. And then right here, it's pretty great because it also gives you information about the official documentation right here, the npm link to npm, GitHub. You can see reviews from people. So it's a great also way to just pick a good package, a good library. And another thing I'd like to do then is I copy then the package name and I go to snyk.io/advisor, and they kind of like provide the same sort of tool, but it's more security focused. So right here, you can see it gives you a package health score. Snyk is more focused on the security side of things. So amongst others, it checks the popularity of the package, the maintenance, some security issues of the versions it had in the past, the community, things like that. But it's good to make that also part of your decision process to determine whether you go for like package A or B. And speaking of Snyk, it's really a great tool to help you finding security problems in your project. I can really recommend you to use it. So in order to use it, you first need to sign up with Snyk. You can go to snyk.io and simply create an account which you can connect to your GitHub account. So I already have an account with them, so I will just log in. And right now, well, you have your dashboard, and there's essentially two ways you can analyze a project. You can either import a project by connecting it to your GitHub. So you can click right here, add project, and click on GitHub. If you have private repositories, you can also do it with the command line interface, which is what I'm going to use. So right here you can see you have to first install the Snyk tool, which I've already done. And well, what you can do, I will go to this project right here. I will enter Snyk auth, and that will then redirect me to here. We'll click on the authenticate button, and now I'm authenticated. And then I can run the command snyk monitor. So I'll get back to you once that's done. All right, so the analysis has been done, and now I can go back to Snyk and go back to the previous page. And now you will see that this project will pop up. This is an old project that I put in my portfolio a couple of months ago. And right here, you kind of like have an overview of a couple of things, right? So it focuses on your dependencies, but it also focuses on, your actual code itself, right? So maybe you have, you've made some, you wrote some bad code, not in terms of quality, but more in terms of security. Then it will also let you know right here. But it also gives you an idea of how, like, what's the severity of the problem. Is there already a fix out there? Things like that. So you can also read about some more details of the issue. So pretty much like what is the problem and how can you potentially fix it. For the ones that are fixable, often you can get rid of, well, most of them using npm audit fix. So that's what I'm going to do right now. So first of all, I will run npm audit fix, and I'll get back to you once it's done. So right now you can see that it has updated quite a few packages. On the other hand, it didn't fix any vulnerabilities it scanned. We can, however, do one package update for the 6 vulnerabilities, but those involve breaking changes. And if we want to do that, we can run npm audit fix -- force. Now, you should understand that this includes breaking changes. That doesn't mean that your app will break, but that's why most of the time you want to have your application tested. So after you did run this command, you can actually run the tests to see if your application is still working. But for now, we'll just copy this and execute this command and get back to you once it's done. All right, so as you can see, it currently fixed 6 vulnerabilities. So I will run the snyk monitor command again, and then I'll get back to you. All right, awesome. So I just did that, and if you scroll up, you can see that we have a link. And when I go there, just keep in mind we had 4 fixable problems, 3 partially fixable problems, and for 16 we had no fix available. Now when I go right here, you will see we only have 3 issues where currently no fix is available for. So that is great. npm audit fix most of the time can fix a lot of the issues. Now for the remaining ones, you know, you have a couple of the, you know, you can make a couple of choices. Maybe you could get rid of the library altogether, but right here you can see they are used by Next.js. So I, well, assume that if I will remove that dependency, the app will seriously break. So that's probably not an option. Probably what you should do is, you know, watch the issue closely. Often in the, if you go right here, you go to the GitHub page, and sometimes someone makes an issue or a pull request with regard to that issue. Just watch it closely and try to update it as soon as possible. Maybe you can fix it yourself, right? You have to make a decision right there, but you can also ignore the issue if you want to. So let's close these guys up right here. Another thing you could use is the snyk Visual Studio Code extension to use snyk code. So when I open up that project right here, you can go right here to extensions and you can search for snyk. And then you want to grab this one right here. It's called snyk vulnerability scanner. And it can also check your code. So I'll just have to enable it right here, snyk. And what you can do is you can, well, you probably have to authenticate, but well, right here you see that snyk didn't find any issues, but this is also a way to use snyk. And another way to use snyk, which is the one I definitely recommend the most, is to let snyk be part of your CI/CD pipeline process. So if you haven't watched my video yet about how to deploy React apps and setting up a CI/CD pipeline, you can check out the link you're seeing currently, or you can also check out the description. But you can use the snyk netlify plugin to use snyk as well. All right, so next up we have authentication and authorization. So I make this mistake very often, that I say like authentication where I actually mean authorization. But let's get it straight, right? So authentication is about validating whether the app is accessed by the right person. So that's essentially, you know, the sign in. And authorization is about checking if a user is permissioned to allow something to do. So think about if the user is allowed to change some details that are stored in a database or something like that, right? And what you should keep in mind is that your authorization should always be controlled by the server. And if you haven't watched my video about form validation yet, right there I'll explain why that actually is. So I will put a link up here. Now, to be honest, authentication and authorization are more like, back-end thingies, you could say, right? It's the ultimate control eventually is not with you as a front-end developer, but it is with the back-end developers. But on the other hand, you have to create pieces of UI to inform the user about whether he is authenticated or not, or authorized or not. So as a front-end developer, you have to deal with it as well. So first, let's take a look at authentication. So again, that's about validating whether the app is accessed by the right person. So that can be through sign in and sign up and OAuth flows. So if you've never heard about OAuth before, the idea is that you, for example, sign in with your Google account, and then Google is essentially going to give you a token which allows you to read data about what the name of the user is, and the email address of the user, and that's something you can then use for the authentication in your app, but you can also use it to store some data in your database. So there are a couple of good practices from like a security point of view. So often like OAuth flows or flows that involve some kind of two-factor authentication are definitely the safest, because like companies like Google and Facebook and all the other OAuth providers have a lot of good security measures in place, and two-factor authentication, for example, with a text message, or using something like Google Authenticator or something like that. It's also a good decision from a security point of view. Now, there's also a couple of other things. So if you're going to use just passwords, then you should prevent users to use weak passwords, right? So like, I don't know, what are common passwords, secret, admin, things like that. You want to block those, right? You want to inform the user that they should come up with a more complex password. What is also good is to prevent account enumeration attacks. So I got a couple of examples right here. This example is from Epic Games. So right here, what you will see, if I'll just enter like a random email address, and I'll click on send email, so this is like a forget password page, you will see that we're going to get an error. It says, sorry, your account was not found. So in this way, I'm able to, essentially find out who actually has an account and who has not. And a good example of preventing this is, for example, what Starbucks did. So they also have this forget password page, but now, how about a real cookie? Not now. All right. So right now, when I put in an email address, which I assume is not used, you'll see that it says, thanks. If you have a Starbucks account, we'll send you an email. And this is great because, now I cannot really know whether this person is actually a real user or not. So this is, I think, something you should also have in place. What you should also keep in mind is that if you, for example, go to the network tab, and let's actually refresh this page. If I, for example, put another email address in here and I click on reset password, the server now responds to 200 response. And that's also what you want, right? Because they could also catch it, for example, right here. So if the server would have responded with like a status code that says that, for example, the user is not found, still people are able then to identify whether a certain email address is used with Starbucks. So let's close this up. Another good thing, but this is more like server-side related, is to limit brute force attacks. So what I did, like just requesting the passwords, you also want to prevent that people are able to do like, I don't know, a couple of more than like a couple of password requests in a minute, because it really wouldn't make sense for like a normal user to request their password multiple times a minute. And another good thing to have in place is to require re-authentication for sensitive features. So for example, if you want to delete your account, you see this often also with Facebook, then you are actually prompted to again provide your credentials to like log in again, and then you can delete your account, right? So for all those sensitive kind of things, try to require re-authentication. All right, let's move on to authentication methods. So generally speaking, you can either have like single sessions or persistent sessions, right? So a single session is where you would log in and then you can well, use the app, but as soon as you close your browser and visit the website again, you have to log in again, which is, well, from like a user experience point of view, of course, pretty annoying, you could say. So you can also set up persistent sessions. That will mean that if a user would come back even after closing their browser or restarting their device, they are still logged in. So they are still able to use the app without having to re-authenticate. And often what you see is that people either use JSON Web Tokens for it or session cookies. Now, I think it's really important to emphasize right here that JSON Web Tokens, although it's very often used for this use case for maintaining sessions, for session management, JSON Web Tokens are not made for that. Okay, JSON Web Tokens are great for other use cases, but they are not designed for session management, and from a security point of view, it's also not very safe. Just stick with session cookies, right? That's the way to go, and that is also from a security point of view the most safest option. So let's take a look how a like a session cookie flow, you could say, looks like. So let's imagine you have your React app, we have our browser, and we have a server. So if a user signs up or signs in or uses OAuth to sign in, you're essentially asking the server to give a session ID cookie, right? And if the server is able to verify that you, for example, entered the right email and password, it's going to give you that cookie, and then automatically the browser will notice that a cookie was sent in the server response, and then it will store that cookie in the browser. And for security measures, this is often done with both the HTTP only and same site attribute. So then, well, the user is actually able to use that session cookie. And that session cookie is essentially to identify that, if the server receives a request, it's able to identify who is actually sending that request, right? So which user is making that request. So let's imagine then we want to make a GET request to a server. Then what kind of like automatically happens, but if you're using, for example, Axios, you have to set, for example, with credentials as true, which is a little bit out of scope for this video. But this will kind of like automatically be done. But what you then can do is you will make a request to the server, and it's going to attach that cookie with the request, and then the server receives that request, and then it's going to process it, and based on that session ID cookie, the server is able to identify that, well, it's, for example, John that is making this request, and it can then send the data back to React. Now, a problem with this is that you could potentially run into some problems, because cookies, generally speaking, have an expiration date, right? That's always a good thing to do from a security point of view. And what you should prefer is a flow that looks somewhat like this. So at the initialization, React is going to send, for example, a request to the server, and it's pretty much going to ask, hey server, is this cookie ID, is it still valid? And then the server, for example, responds and says, yes, it's still valid, but it expires at a certain date and time. And well, then you can just go on with React and continue making your requests. But what's nice about this is that now you have like a date and a time to determine, whether you should like automatically log out the user, right? Because a scenario, what could happen if in this flow is that the session cookie has expired, but it's still like stored in your browser, and like in your React app, your user is still logged in. So your user will then make requests to the server, and it will constantly get error messages because, well, the server was not able to verify that you are authenticated. So if you would do it in this way, you can, and then you can notify your users that they, for example, their session expires in, a certain amount of time, and often those cookie expiration dates are set like, weeks or months after the login. But it's still good to have something like this in place to, prevent quirky behavior and just like a weird experience for your users. All right, so the next topic is sensitive data. And that's pretty simple because you should never store sensitive data in your React code. And like I said before, the video that I made about form validation in React, there also talk about this. But the problem is that everyone that is using your React app could essentially read the source code and, well, is essentially able to read your code and modify it. So that's why you never want to store any sensitive data in your React app, right? So if you have sensitive data, always, put it on a server or like in a database, which then can be accessed through a server by requiring authentication and authorization. You also have environment variables in React, and well, some people think that environment variables are a safe way to, for example, put API keys in your application, but that's not the case, right? So also with environment variables, whether that is by creating a .env file in your React app, or putting, for example, setting up some environment variables with let's say Netlify, which is also possible if you're going to deploy your application, everyone is able to figure out what those API keys are. So you shouldn't store that, your API keys or anything like that in your React app. But there are essentially most of the time two ways you can secure your API keys. So you can secure your key with the API provider. So for example, if you're using the Google Maps API, they allow you to kind of like protect the API key, where it essentially says that it's only used to allow it on a certain domain. So even if someone else would steal your API credentials and try to use it for their own application, with of course another domain name, it will not work. So that's one way. And another way is to make a call through a server. So how that looks like is that your React app is going to send a request to your server. Then your server is just going to make the API request, and of course the server then should have the API key, but the user is not able to find out what that actually is. And then the server gets a response from the API, and then the server eventually then is going to, well, respond with what it actually got back from that API to actually let React know that, well, this is the outcome of the API call. So the next topic is about protecting your React source code. So there's this process called reverse engineering, and well, with respect to your React source code, that means that people could try to find like weak points in your applications. And you cannot completely prevent this from happening, but you can definitely make it very hard for people to understand how your code is actually working by a process called obfuscation. Now, what I did is I have my personal site I built right here. I just served it locally on port 5000. So as you can see, this is my site. And by default, and this might surprise you a little bit, but when I go to the sources tab in my Chrome DevTools, you can see right here on the localhost 5000, when I go to static and I go to JS and I go down here, you can simply see all the code of my app. So when I go to pages, for example, this is the home page, then you'll see I can open the TSX file, and I'm actually able to see, how the app, like the actual code I wrote to create this. And the reason why this is possible is that it is more intended to aid debugging. So if, for example, any errors occur in your application, then it could, for example, direct you to the place in your code base where things went wrong, and well, it will help you with debugging. But if you want to prevent this from happening, what you could do is you could first of all put the following line in your .env file so it doesn't generate that source map. So you can do generate _ source map false. So I'm actually going to do that. So you can create a .env in the root of your application, and then you can say generate underscore source map equals false. And I will save it and I will rebuild the app. So I will say npm run build and serve as build, and I'll get back to you once it's done. All right, so it seems to be done. So let's take a look right here. So I will open up my DevTools again, and now you'll see that we have that same static folder, but now when I go to JS, you see that the source map is gone. And now we do have like the main chunk. And by the way, if you don't exactly know what this is, I recommend you to check out my full React course, which is available right here on YouTube. And there we get into, well, also these kind of things, what it actually means and how it works. But right here, when I click on Pretty Print, you will see, this is actually the source code. So this also contains the code of the homepage. But as you can see, everything is like minified or uglified, and it just it's a lot harder to understand for someone what's going on. Now, you can go one step further and you can add a JavaScript obfuscator to your project. You have a separate library for this, which you can install and configure. But if you're using Netlify, which I always highly recommend because it's a really great service, then you can use the Netlify plugin JS obfuscator, which is very simple. You can simply install it, and that will well, let's actually take a look what it will do with your code. So if we go to, because what I said, like the Netlify plugin JS obfuscator is built on top of this library, right? So the JavaScript obfuscator library. And right here, they give a bit of a demo of what it does. So as you can see right here, we have some JavaScript code, and what it then will do, it will make this out of your code, right? So it makes it even harder to understand what's going on, and there's all kinds of settings you can change as well. But if you're really concerned about your source code being like, well, possibly reverse engineered, then I recommend you to do something like this. But do understand that it is no guarantee that people will not eventually find out what your code really looks like. So next up we have HTTPS, which stands for Hypertext Transfer Protocol Secure. And the idea is that you have an SSL certificate, which contains a public key, which is used by the client and server to establish a secure connection through a TLS handshake. And the idea there is that the data that's being sent back and forth between the client and server is encrypted. So imagine that I would send like a physical letter to someone I know. Someone at the postal service company could steal that letter and could read it, right? And on the web, it's essentially the same, right? If someone wants to, he can intercept what's being sent between the client and server. However, if you're using HTTPS and that secure connection is established, then a person is still able to retrieve that data, but he would receive a lot of gibberish because it is encrypted data. And the only way for that person to read what's actually being sent over is to have both the public and the private key. So without getting too much in details, that person is not able to understand or read what's actually going on because it's encrypted data. So if you want to make sure that your site is using an HTTPS connection, the solution is very simple. Just get yourself an SSL certificate and configure it. And if you use a service like Netlify, you can get that certificate for free and it will automatically be configured. So it's just like 1 or 2 clicks and you're set. And especially as of today with modern web applications, there's really no reason not to use an SSL certificate. So, just always use it. So last but not least, let's move on to the application security tools. So there's a couple of tools you can use. Very popular ones are so-called SAST tools, which stands for Static Application Security Testing. And what it essentially does, it tests your source code or your compiled code. And we already used one before, Snyk code. Snyk is, what you would consider a SAST tool. There's another extension I can recommend you for Visual Studio Code. It's the HCL AppScan Code Sweep. As you can see, we have it right here. I already have it installed. So open up back my own project. As you can see, Snake has done an analysis, and don't worry, my app is safe. But right here it complains about things like no catch method was provided, but actually this is in a try catch block, so I can simply ignore this. But I already have the app scan extension installed, but of course you can do that through here by looking for app scan, and then you can install the extension. So as you can see, my app is currently, well, nothing shows up right here, but if you have any like vulnerabilities in your application, it will show it right here. So you can also see right here, you have some security rules. It supports React, and you can also see what it actually well, detects, and it by the way is also for I think TypeScript. Let's go down a little bit. Yeah, TypeScript as well. So again, a great tool. Just keep this activated once you're working on your code base, because this will only work if you save a file. Then it will kind of like check if your code is, well, saved, you could say. Another type of tool that is quite popular are DAST tools, which stands for Dynamic Application Security Testing. And what that essentially does, it is testing your application from the outside. So instead of going over the source code, it's going to visit your site pretty much just as a real user would do, and it's going to try to find like security vulnerabilities. The problem is that, especially with React apps, modern web applications, it's still a pain in the ass. Honestly, it's there are like to what I know, I tried a couple of tools, but there are just not really a lot of good tools that are able to handle like more complex sites that are, for example, built with React. So who knows what the future will bring, and if you have ever found like a good tool yourself, let me know down in the comments. But for now, I think that there are not really good tools out there. On the other hand, for like backend, like Node.js and stuff like that, you have some pretty good tools out there. But unfortunately, front end is still something something in progress, I'd say. And you also have so-called code quality tools. Now, code quality tools are not necessarily about security, although code quality does have some correlation with security. And a tool I really like is DeepScan, which well, essentially it's somewhat comparable to your SaaS tools, right? So it's going to scan your source code, but this is more with respect to good coding practices, you could say. So you can simply sign up by logging in with your GitHub account. For like projects that are open source, it's free, and for projects that are not, there's like a pricing plan. So as you can see right here, part of my React course, I did a test on the Cypress video I did about testing. Well, as you can see right here, 138 or actually 206 lines of codes were scanned, analyzed 8 files, found no problems at all. And right here in my TechBase app, you see it's not perfect. If I scroll down right here, you see that it has about 4,000 lines of code, 37 files. And when I go right here, these are just some stupid mistakes. But as you can see right here, it, for example, notifies me that the condition user is always true at this point because it's already checked at line 1, 2, 3, which I've done multiple times in the code base. So that's why I have like 7 of these errors. So but again, that's also a good practice, right? Scan your code base and make sure that you are implementing good coding practices. So what I would like to emphasize, that this was not an exhaustive security course, right? There's a lot more to web security. However, my goal of this course was to create something that gave you some tangible advice, and tools you can use on a daily basis to make your React app a little bit more secure. If you go out on the web and you look for React security articles, most of the time you'll read a lot of awesome stuff, but it gives you very little to actually work with, right? Something that's often mentioned is like dangerously inner HTML. And I think it's good to talk about that for a minute as well, because, out of the box, React has a lot of good security practices in place, right? So if you want to use like inner HTML in your React app, you actually have to use dangerously inner HTML. Like, if you're going to use something like that, probably an alarm bell should go off, right? You should probably notice that probably something is dangerous about that. So, you know, use your common sense as well when it comes down to security. And but I hope this course gave you some, you know, some good tangible tools you can now use on a daily basis. So another thing I'd like to mention is OWASP, which stands for the Open Web Application Security Project. This is where you can read like so many good stuff about security. And they have the OWASP top 10, which are like the, well, like you could say like a top 10 list of security threats to web applications. They keep that up to date like every year. It's very popular. And there are like thousands of pages right here on OWASP that are like fully dedicated to web security. There's like a ton of information right here. So I can definitely recommend you to, take a look at the site and then just stroll a little bit around and then see what you can learn. So having that said, thanks so much for watching. If you liked the video, consider subscribing, giving it a thumbs up, and if you have any questions, let me know down in the comments. Having that said, thanks so much again, and I'll see you in the next one.